Okay, I'm recording. All right, so we're going to use this data to figure out the average atomic mass for our chlorine. This is from data from a couple years ago because the solvent no longer has chlorine in it. That's why we're using it, and it's a post-lab question instead of actually part of our lab anymore. Okay, if you remember, you take the mass of each isotope times its percent, add those numbers together, get your total, divide it by 100, which takes care of our percent sign, and that is your average atomic mass. All right? So, with this, and do not use the data I am about to make up because I am not going to use the exact data. All right? We have two isotopes, chlorine 35 and chlorine 37. All right? I'm just going to throw this on here. You should set the 0 right on the peak or right on the origin, and then measure to the peak or measure the origin. All right, I'm just going to put it on here and make up a number. All right, and we're going to zoom in. All right, so we can see, and I am going to, all right, if we look right now, this one is at 21.123, about 3.5, right? Okay, so 21.3.5, which would be 21.35 centimeters. You should have two decimal places. So the question might come up, what if it comes out exactly on a line? Would that question come up? Could somebody ask that question? Go ahead. I'm glad you asked that question. If it comes out on exactly on the line, let's say it was right on the 3, you would write 21.30 to indicate it was right on the line. Does that make sense? If you don't have these measurements out to two decimal places, then you will lose partial credit on your answers. I have said this over and over again. So we'll do it again for this one. All right, and this one, let's say it does come out exactly on line. And I've got 7.567, so I would say 7.70 centimeters for this line. And again, guys, do not use these numbers. I did not put this right at the starting points of the things. Okay, so now these calculations, you can write right on your sheet. That's your sheet to use. These calculations I'm about to do go on those post-lab questions, all right? What you're going to do is get your total height. What's that mean? I add these two numbers together, whatever your numbers are. Again, you are going to be estimating. You might estimate it slightly different than the person next to you. That's okay. All right? So I'm going to take the two numbers. I am going to add them together. Oops, put my plus in the right spot. All right, so I got a 5, I got a 0, carry the 1. 7, 8, 9, so 29.05. That is my total height, right? To figure out my percentage for the chlorine 35, I would take my 21.35 divided by 29.05 and times 100. Now, again, yours will not be this. I'm making numbers up completely. 21.35 divided by 29.05. And so that would come out to be 73.49%. All right, and then my chlorine 37 would be the other part, 7.70 divided by 21.35 times 100. And so that will equal, divided by, oh, not divided by, I divided by the wrong number, divide by the total, 29.05. So 7.70 divided by 29.05 for mine. And I get 26.50, or excuse me, 51%. Okay? All right, and that's for my chlorine 37. So to get your average atomic mass now, you take the 35 times 73.49%, and 37 times 26.51%. All right. 37 times 26.51 equals, so this one comes out to be 980.87, 73.49, and this one comes out to be 2,572.15. All right, and then we're going to add them together, and we get 35. Wow, this is actually pretty darn close, because I was just making stuff up. 3553.02. Then take that, because of the percent, divide it by 100. So my answer will be 35.53 AMU. Are you with me? That's what I got with my made up data. All right. Now, technically, we should go with our smallest number of significant digits, which would be the 7.70, but I want you to keep 4 significant digits. We're going to cheat it just a little bit. All right, so keep 4 significant digits. Technically, and I don't know if we can get this data from here. It'd probably be more accurate if we actually use the count number that made the graph. All right. After you get it done, after you get this, it asks you to compare it to what the standard or the actual value should be. Just a second, and I will give you that value. All right, what you should come up, if this ran right and we got perfectly good data, and we would also need to, instead of just using 35 and 37, get the exact mass for each of those isotopes. The actual or accepted value, the actual value should be 35.453 AMU. All right, use that and your answer and do a percent error, and that's how you can compare it. All right, does that make sense? Do you guys see how to do that? Not super difficult. So that way you can finish up that part of the lab. All right, I have a ton of rulers. Okay, let me stop my video.